This video is on significant digits and precision. It used to be a section in your book and then they took it out, but they still kind of assume that you understand what significant digits are and what we mean by precision and how to use it. And so I'm going to go ahead and kind of work through these notes because you need to know. So there's no number for the section. There's not a specific assignment that will go through this, but as we go through sections, specifically in chapter 2, but even a little bit in chapter 1, they're just going to assume that you understand this and that you have working knowledge of these words and that you know what they mean when they say significant digits. So first, significant digits are the number of digits in a value or measurement necessary to decide the accuracy or precision of the measurement. So I'm talking digits like how many digits are in the number, and then of the digits in the number, which of them have a significant value. And then the precision is the level of exactness in a number's digits. So of the numbers that you can see, how precise are they when they measure something? All right, so for significant digits, there are two things to remember. First is that digits other than 0 are always significant. So if you have a number 1, a number 5, a number 7, that's always going to be considered a significant number. Second is that 0 is not significant in two situations. The first is that when you have a whole number and the zeros are to the right. So here's a whole number, we got zeros to the right, none of these zeros are significant. The other is when you have a decimal number and you have zeros on the left. So here's a decimal number, we got zeros on the left. The zeros on the left are not significant. Okay, so zeros here, not significant. All right. So those are the two things you're going to remember with your significant digits. The reason we care about significant digits is it helps us with rounding, so that if we're adding numbers together or multiplying numbers or doing whatever, if they tell us to round according to the significant digits, we can say, oh, well, that number had two significant digits, so I'm going to keep two significant digits in my answer. Okay, so here it says how many significant digits does each of the following numbers have? So this is a whole number. That means we're going to ignore the 0 on the end, because for whole numbers we ignore any 0 that's on the right end. And then anything that's not a 0 is going to be significant, and any 0 that's trapped in the middle ends up being significant because it doesn't fit this second rule. So this has 3 significant digits. This is a whole number. It's not a decimal. It's not part of a number. None of these are significant. None of those zeros are significant. That means we only have one significant digit. Over here, this 0 is on the end, but it's not on the end of a whole number. So that means in this situation, it would be considered significant. All of these other numbers are also significant because they're not 0. So here, all of the numbers are considered significant, and we have 6 significant digits. For this problem, the same thing is true. We're not talking about a whole number, we're talking about a decimal. The zeros are in the middle, they're not in the front, and so here all of these numbers are significant. And so that's 1, 2, 3, 4, 5, 6, 7, 8. That's 8 significant digits. This is kind of a unique case. You're probably not going to see this, to be honest. But if you have a 0 with a line over it, they're giving you an indicator that they want you to have more significant digits than it appears that the number has. So it looks like it should only have one significant digit, but they're telling you that this number here is also significant. And so if this is significant and this one is 2, then everything in between has to be significant. So the only one that's not is the one on the end, because this is a whole number, and zeros on the end are typically not significant. So this is an exception to the rule. Honestly, I didn't really see it in this course, but I thought I'd include it just for information's sake. And then over here, we've got one of those decimal numbers, and we're going to ignore all of these zeros here. But we're going to use this one over here. We use the 0 on the end in this case because this is not a whole number, it's a portion of a number or a decimal of a number, and so we use zeros on the right in that situation. So this has 4 significant digits. So here we have another vocabulary term, the accuracy. The accuracy of a measurement refers to the number of significant digits that it contains. And so if we were adding numbers up that have like one significant digit here, the accuracy of this number is going to be to the 10,000s. That's the accuracy of the number. So if we were adding this to another number that had a lot of significant digits, we'd be like, yeah, but this one only was accurate to the 10,000s place. So even if the other number was, I would probably assume that the two numbers added together are probably only accurate to the 10,000s. This number here is accurate to the tens place, thousands, hundreds, tens place, but it is not accurate to the ones place. So that's kind of what we're talking about when we're saying the accuracy is we're talking about how many numbers in there, how many digits of accuracy we have. So if they're asking find the accuracy, they're just saying tell us the significant digits that are contained in the number. And so it's the exact same thing as if they said, tell me how many significant digits there are. Find the accuracy, find the number of significant digits that are contained in the number. So here, this is a whole number. We're going to ignore the zeros on the end. And so this has 4 significant digits. This one right here, we've got zeros on the end, we got zeros in the middle. This is a decimal number, and so we're going to include the zeros on the end. We're going to consider those to be significant. So this is 1, 2, 3, 4, 5, 6, 7 significant digits. Here we have a decimal number, so the number on the end, the zero on the end, is significant, but the zeros on the front are not. So we've got 2 significant digits. All right, next, precision. We already described it as the level of exactness in a number's digit. So the precision is indicated by the place value of its rightmost significant digit. The rightmost significant digit. So here, all of these numbers are significant digits. And so the rightmost significant digit is right here. This is the ones place. Right here, it's the ones place. So this is accurate or precise to the ones place. So if I was adding this to another number, I could add to the ones. Now this number right here, it only has this number as a significant digit. It's a whole number. It's got all these zeros. These are not significant. So the precision here, it's precise to the millions place. None of these numbers are precise. It's precise to the millions place. So if we were to add this and another number together, we'd want to say like, oh, when I add them, I get 6 million. When I add them, I get 8 million. When I add them, I get 9. Or when I subtract them, I get 4 million. But I wouldn't want to be more precise than that. Over here for this number, when we look at this decimal, we don't have any zeros in front, so we don't have any zeros that we're going to say are not significant. We have zeros on the end, but they are significant because they're on the right side of a decimal number. And so we are precise to this place right here, and so we're going to kind of list them off. It's the tenths, hundredths, thousandths, 10,000ths, 100,000ths. It went a little bit further than this did. So this is the 100,000ths place. This was the millions place. This was the ones place. So if you're to the left of the decimal, if you're talking about whole numbers, then it's ones, tens, hundreds, thousands. If you're to the right, if you're talking about a decimal, that's where you have the TH. And there's no such thing as the 1th place. It starts with 10th, 100th, 1000th, 10,000th, then 100,000th, then millionth, 10 millionth, 100 millionth, and so on.